Welcome back to the afternoon section. My name is Yi Cui. I will be moderate the class 2. As you can see from the report, class 2 includes many chapters. It's a very important part of the energy assessment. It includes energy resources and technology options. You can see from the report, we have energy generation, all the resources where you can find energy, to energy transformation, delivery, and efficient use of the energy as well. So in this afternoon section, we are lucky to have a very distinguished panel of speakers and discussants to talk about selection topics in this area. Let me do a quick introduction for all the speakers. We have Robert Schock as the first speaker. He's the Senior Advisor and former Director of Studies for the World Energy Council. We will have Diana Urch-Wassets. She's a professor in the Department of Environmental Science and Policy and Director of the Center for the Climate Change and Sustainable Energy Policies at the Central European University. And then we will have Wim Turkenberg, who is the Emeritus Professor and former Head of Science and Technology and Society Department of Utrecht University. And we will have Sally Benson also coming as the last speaker to talk about carbon capture and sequestration. So after that, we will move on to the discussion and panel discussion. We will have Arun Majumdar from Google Energy, who is the previous, also the founding director of DOE ARPA-E, and Alexander Ox, who is the Director of Climate and Energy and the Woods Watch Institute. Now let's start by the first speaker, Bob Schock.
Thank you, Yi. Get wired up here. The key word in this talk is systems, and I'm going to keep coming back to that. And I think it's appropriate, although we did it in the reverse order in the GEA, it's appropriate to talk about this first, because if you think about it, all of the individual technologies which we all love and love to get involved in, if we're really going to make anything happen, we have to talk about how it fits into a system. So the emphasis in my remarks will be on the system. And if you think about it a bit, if you're a technology investor or a technology industry, really, a financial investor, or even a policymaker, and somebody comes and wants to, wants to invest in something or make something happen, the first thing you're going to ask is, what's the system? So look, going forward, systems have always been important, but they're going to be even more important. So I'm going to try to convince you, we are going to try to convince you, we who did this chapter, that thinking about systems is something that has to be done. That's not to minimize any of the individual technologies. The second key word that I'm going to stress is changes, and try to give you an inkling of the changes that are taking place now and are likely to take even more place more rapidly in the future. You will note that I've put two names down here because there are two chapters that deal with energy systems. One with energy systems today and how they're evolving today, and another one looking way out into the future. And Anand, who will be here tomorrow, led chapter 16. But we worked together and we tried to make a smooth transition. So when you read the material, you probably ought to go from from one to the other. I'm looking at the clock up here, but it's not moving. That's good. So that's the first slide. And this is just the almost obligatory but very important indication of the people who worked on Chapter 15 and Chapter 16. Energy supply systems really are very complex. And this is an oversimplification. I don't expect that you will be able to read anything, let alone everything. But basically, we go from various energy sources down here up through energy carriers. In some cases, the source is the carrier, for example, natural gas, and up to a whole bunch of end uses. And in the report, we've tried to indicate which ones are important and becoming more important, and which ones are not important now but might become very important in the future. Now, now I'm going to be timed. There we go. So in terms of future energy systems, the report talks about providing, and we heard a lot this morning about providing affordable energy services to everyone by 2050. Naki had several slides that said 2030, and you forced me, Naki, to go back and look, and I did find 2050 in the report, but it doesn't matter. At some point in the next 20 or 30 years, 40 years, the goal is to provide energy services to all. Now, I put the next bullet down because that tends to lead many people, I think we're all past that, many people to gravitate toward rural areas where people don't have access to energy. But I put down cities are the key because if you think about it, so many things are happening in urban areas, and the affordable part applies to urban areas as well as rural areas. And the point I want to make, or we want to make in the chapter, is that anything that's done to deal with the problems of in cities will benefit people in rural areas. Arnulf, a little bit later, is going to talk about urban energy systems, so I will not go into it any more deeply other than to leave you with a couple of numbers that tend to get lost. Over the next 20 or so years, we can expect in the world to see something like 10 cities of 7 million people, new ones, every year. Usually when you read this or when I talk to people, their eyes glaze over because they begin to think of that many cities over the 20-year time frame, but it's every year. So cities are I want to amplify on what Arnulf will say, cities are terribly important, particularly in terms of energy systems. That's what I want to talk about here, because that's where we can probably do the most good, and the rural areas will benefit from what gets done in those areas. And not to be overlooked, if you're an energy industry, the markets are tremendous in the urban areas. They're not quite so robust in the rural areas. So we need to, my point is we need to think in terms of cities. Also want to, the report makes a point that the energy systems that we're moving into need to be made much more flexible. And there are two main drivers of that. One is the kinds of technologies that are coming along to be able to adapt to those technologies. And we're not sure which are the winners and which are the losers, but flexibility is key to doing that. And also rapidly changing social needs. And electricity is a good example. Kurt talked about it this morning. I'll talk about it in a minute. It's an example of being flexible. In that chart I showed a few slides ago, it's an example of being flexible from the sources to the end uses. Lots of energy sources can be used to make electricity, carry things through, and then lots of different end uses. The last bullet was touched on again this morning, and we'll touch on it more later, and that is, in order to implement the systems of the future, and this is amplified in the report, the existence of stable governance policy frameworks is required, and that tends to very often get overlooked. But the point I think we need to make and continue to make is that technologists and financial institutions and policymakers need to work together and get into a stable situation. We had a brief conversation at lunch, and I'm sure you'll hear more in this session. There's some critical questions that come out. There are lots of questions in the chapters that I'm talking about, but some critical questions are, will the future competition be between energy sources? If we go back 100 years, that's more or less where we started, but things are obviously changing. Will it be between end uses? Will it be between sources and end uses, or integrated systems? We have some ideas, or could be some combination of all of the above, but we need to keep that question in mind. And then Kurt talked a bit about intelligent energy systems this morning. We'll talk about some more, but I think we need to keep asking the question, what does an intelligent system look like? We don't think it's cast in concrete. In its overall outline it is, but in detail it's not that clear. And will we know one when we see one? So let me begin with electricity. As we've said, it has the ability to transform a broad array of resources into useful goods and services. A statistic that's in the report, which I find interesting, and I think you will too, that if we could double the amount of electricity that's projected in 2050 in a business as usual scenario, we would probably get, given what we know about how electricity interacts in the world today, we'd get a 2/3 reduction in carbon emissions. Some of that is efficiency. A fair bit of it is. And we'd get a 50% increase, roughly, in economic output. Kurt, by the way, who just came back, was one of the, if you didn't notice, he was one of the authors of Chapter 15. So the goal is to get everyone up to at least where advanced economies are today, roughly 2,000 kilowatt hours per year per capita. The U.S. is about 6 times that, a little more than 6 times that, if you're looking at comparisons. And then to repeat what I already said about cities, in 2050 it's expected that 2/3 of the population of the world will be in cities, in urban areas. And there will be fundamental changes in infrastructure, really centered around more control of the infrastructure. Things like small distributed power units, things we're seeing today, low voltage generation, combined heat and power, CHP, active control and balancing, and increased use of ICT, information and control technology. This is an example from a paper by Clark Gellings, who is here somewhere, which Kurt has used quite a bit, but it's a good example of a smart electricity grid. You will notice that there are offices, housing areas, a wind farm, an industry, and a central power, the conventional central power plant. all integrated and all connected in real time with the digital grid, so that decisions can be, the system can be monitored, decisions can be made, and as Kurt pointed out this morning in Hurricane Sandy, people who lived in or worked in areas that had their own integrated grid basically survived the power outage, which a fair bit of the Northeast, by contrast, was out of power for about 2 weeks. The other point I want to make, and my time's running out, is look at these little canisters that are used here to indicate energy storage. We briefly got into energy storage this morning. This points out how important energy storage is, and one of the it's throughout the whole system. It's in the neighborhood, it's in the farm, it's in the industrial plant, and we need to do a great deal more to improve storage. So if there's an area that demands increased R&D, one of the areas is storage, and I could talk about that a lot more. I put down here a defining role for storage and needed research. This just shows you why you need storage. This is New York in the summer months, where the peak power goes really up and causes problems. I want to talk about, we could talk about a number of different systems. We could talk about a natural gas grid, for example, but we talk about all of those in the chapter. Here, I just wanted to mention hydrogen. It also, like electricity, has the potential, has the flexibility, and the societal advantages, and the technology is there, and it's in a whole bunch of things. It's used in a whole bunch of different areas today, but a key are fuel cells. And if there's an area that needs a great deal of research now, it's fuel cells. I like to think of a fuel cell as an electrolyzer run backwards, and that fits into the grid concept, that you can take water and you can make hydrogen, or you can use hydrogen to make water and get energy out. Put energy in to make hydrogen, get energy back out to use the hydrogen. It's also, next to the last bullet, an excellent storage medium. So you can be using electricity, and that's one of the ways you could potentially store it. So the development of fuel cells is key. This just shows you, not to get into Wim's talk, but if all the different ways you can make hydrogen from renewable energy. I'm going to skip over demand-side management in the interest of time, but there's a great deal of that in the report, and it has a tremendous potential to make whatever grid you're using much more efficient. And there's an example at the bottom of electric peak clipping and valley fillings and load shifting, and this is just a pictorial which shows the same thing. This, you have to go to the report. I don't expect you to be able to see this, but this shows the potential combinations, the real and potential combinations of various technologies, too many to even read on here, with different colors indicating where they are in their current development. So I put this in here to give you an indication of the kinds of things that are going to change our world in the next 10, 20, 30 years. So what's the future? The technologies are available now, but they need more sustained investment in supporting policies. And where are we headed? To answer the question of where are we headed, I think we need to look at innovations and experimentations, the kinds of things that are going on. I should say we do. It's in the chapter. Things like hybrid systems, look at sources and production, combined heat and power, much more of consumers being producers, simultaneous delivery of energy and non-energy services. You'll see much more of that. We're already seeing a fair bit of it. Storage, I think we'll see things in storage, distributed generation. I want to mention ESCO's India. That's an energy services company that basically provides things, and there are examples today in India that seem to be working well. So our bottom line is expect great changes, expect rapid changes, expect winners, expect losers, and expect surprises. So, thank you.